In this video, I'm going to continue to show you how to do basic matrix operations by hand. In the previous video, I was adding, subtracting, and multiplying. In this video, we're going to move on to determinants and inverses. So first up, we need to find the determinant of matrix E. When you have a 2 by 2 matrix, the determinant is just the down diagonal minus the up diagonal. So it's pretty simple. So when I say the down diagonal, I'm thinking multiplication. So this is going to be just 8 minus 8. So that is going to be 0. By the way, these vertical lines that look like absolute value, in the context of matrices, it automatically means determinant. So on a test or a quiz, even if I didn't say find the determinant, even if I didn't use the word determinant, if I say find this and I give you these vertical lines, you have to know automatically that that means determinant. And Tyler, remember not to use those vertical lines if you're not doing the determinant, because it means determinant. So next we need to do the determinant of matrix D. Again, that's just going to be down diagonal minus up diagonal. So in this case, the down diagonal is negative 22, and then minus the up diagonal, which is 24. So that's going to be a negative 46. All right, doing the determinant of a 3 by 3 matrix is a little bit more complicated. First thing you have to do is pick which row you're going to use. So the smaller the numbers, the better. Ideally, there'd be a bunch of zeros and ones. I'm going to go ahead and pick the middle row because the numbers are relatively small. All right, but you can pick whichever row you want. Now, in the back of my mind, I'm keeping this pattern of signs in mind. Plus, minus, 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 and plus, minus, plus. Okay? This tells me what to do with these numbers. A minus means do the opposite sign. A plus means keep the sign the same. So these cofactors, the 1, negative 2, and 3 are called cofactors. And because of the minus, I'm going to put a negative 1 in front. All right, and then I'm going to have a minor matrix. And then I have the negative 2. Because of the plus, okay, of the pattern that I'm using, the plus tells me to keep that the same. So I'm going to keep it a negative 2. So I'll have negative 2 times the minor matrix. And then I have the 3. The minus means I need to do the opposite of that. So I'm going to do negative 3 times the minor matrix. Now, what about these minors that I keep referring to? So as I begin to use the cofactor of 1, all right, that's in column 1. So I'm going to mentally cross out the first column, and I'm also crossing out the second row. Basically, I cross out the row and column of the cofactor. And look at the 4 numbers that are left. So that's why I'm going to have 5 and negative 2 and negative 5 and 1. All right, if I do the same thing for the next cofactor of negative 2, then that means I need to cross out the middle row. That leaves 3, negative 2, 4, and 1. If I do the same thing with the third cofactor, okay, I'm talking about the 3, that means I'm crossing out that column. That leaves behind 3, 5, 4, and negative 5. So notice I'm using these straight lines, these vertical lines. That's because these are not just matrices now. This means determinant. I'm taking the determinant of each one of these minor matrices. Okay, so as we saw a minute ago, if you're going to do the determinant of a 2 by 2 matrix, it's just going to be down diagonal minus up diagonal. Okay, so now I'm going to do down diagonal minus up diagonal. So the down diagonal is 5. The up diagonal is 10. So that's 5 minus 10. Down diagonal is 3. The up diagonal is negative 8. So this is 3 minus negative 8, which is really going to turn out to be 3 plus 8. So watch out for your minus and negative. Here the down diagonal is negative 15. The up diagonal is 20. So negative 15 minus 20. All right, so of course that's going to give me negative 5, 11, and negative 35. What's that going to be? Positive 90, 105. And then if you add these three numbers up, you get 88. So that is the final answer for the determinant of matrix B. All right, finally for part D, we're supposed to do the determinant of matrix C. But this is going to be not possible because you can only take the determinant of a square matrix, like a 2 by 2 or a 3 by 3 or a 4 by 4. So the determinant of matrix C is not possible because matrix C is not a square matrix. All right, for problem number 3, we're switching over. Now we're talking inverses. So keep in the back of your mind, if you're going to find an inverse, the first step is to find the determinant. And you can only find the determinant of a square matrix. So thing number 1 is you're going to need a square matrix. It cannot have a determinant of 0. So those are the two main things that you have to keep in mind. So let's go ahead and find the inverse of matrix D. The first step of finding the inverse is to figure out what's the determinant. So the determinant of matrix D, I think, is something that we found a minute ago. So I don't want to have to rethink that. The determinant of matrix D was negative 46. So we have negative 46. Okay, the next step of finding the inverse is to do the reciprocal of the determinant. So I'm going to do negative 1 over 46. And then you multiply that by what I call the reverse negate matrix. Okay, so looking at matrix D, again, I'm talking about the down diagonal and the up diagonal, as I often do. So when I say reverse, I'm talking about reversing the down diagonal. And when I say negate, I'm talking about negating the up diagonal. So reversing the down diagonal means putting negative 11 here and positive 2 here. When I say negate, I'm just changing the signs. So negative 6 will become positive 6, and negative 4 will become a positive 4. So multiplying by 1 over 46 is really just dividing everything by 46. So this would be positive 11 over 46 and negative 4 over 46 and negative 6 over 46 and negative 2 over 46. All right, of course, we will reduce everything that we can. So for the final answer, you're going to have 11 over 46. But then we're going to have negative, whoops, I don't need another negative. But this will reduce down to 2 over 23. And this will be negative 3 over 23. And negative 1 over 23. So this should be the final answer. All right, this is the inverse of matrix D. All right, next we're supposed to find the inverse of matrix E, but this is going to turn out to be not possible because the determinant of matrix E is 0. Okay, which we found on a previous problem. All right, the determinant of matrix E we found to be 0. And you can't do the inverse if the determinant is 0, which makes sense because the first step of doing the inverse is to do the reciprocal of the determinant. So if the determinant is 0, that's going to give you 1 over 0, and that's undefined. For part C, you need to understand that this little negative 1 automatically means inverse. Even if I didn't say find the inverse, if I didn't use the word inverse, the little negative 1 exponent in the context of a matrix tells you that you need to find the inverse. So again, step 1 of finding the inverse is to do the determinant. Okay, I'm going to call this matrix Q, just for fun. So now I'm going to find the determinant of matrix Q. So that's down diagonal minus up diagonal, so that's going to be 12 minus 6. Okay, so the determinant of matrix Q is 6. All right, so now that means my next step is to do the reciprocal of that times the reverse negate matrix. So once again, I'm talking about the down diagonal and the up diagonal. Okay, so if I reverse the down diagonal, that means I'm going to have 1 and 12. And then now I'm going to negate the up diagonal. So I'm doing reverse negate. So negating the up diagonal. Right, this will give me the inverse. All right, in fact, I should put a little Q inverse in front of all of this. So that's going to give me 1/6 and negative 3 over 6 and negative 2 over 6 and 12 over 6, which of course we will reduce everything we can. So we'll have 1/6, negative 1/2, negative 1/3, and 2. Okay, so this is the inverse that we were being asked to find. For problem number 4, I have this matrix equation, and I'm supposed to find the value of each unknown. Okay, so first of all, let's just go ahead and do this multiplication and see what we have. Okay, so if I did that, if I multiplied all these by 3, of course I'm going to have 12 and negative 6 and 15 and 33 and 24 and 3. So there, I multiplied everything by 3, so great. Now that's going to be plus. Now if I multiplied all these by x, I would have 2x and 0 and negative 4x and xy and 5x. Okay, and that all of that has to be equal to 16, negative 4, 15, 25, 37, and 13. Okay, so if I look at corresponding elements, for example, here I have negative 6, and I have x, and I have negative 4. I could build a simple little equation out of that, because when you add matrices, all you do is you add corresponding elements. So that means that negative 6 plus x must equal negative 4. Well, adding 6 to both sides, that tells me that x must equal 2. So that's one of the things I'm supposed to find. All right, the other variable is the y. So let's take a look at those corresponding elements. So I have the 24, I have xy, and I have 37. Okay, so that means that 24 plus xy must equal 37. So if I subtract 24 from both sides, that's going to give me that xy is equal to 13. So that means if I want to find y, I need to divide both sides by x. But in fact, remember, x is 2. So I can replace x with 2. So this becomes 2 times y is equal to 13. So dividing both sides by 2, that tells me that y is equal to 13 over 2, or 6.5. All right, as you consider part B, this is matrix multiplication, guys. So if you do your little dimension analysis, this is a 3 by 3 matrix times a 3 by 1 matrix. For this to be possible, the inner dimensions would have to be the same, which they are. And then the outer dimensions tell you the dimensions of the actual answer, the product. So your final answer has to be a 3 by 1 matrix. So that means you should go ahead and set up for yourself a large 3 by 1 matrix. All right, 3 by 1. So that means 3 rows, 1 column. All right, so that's what I'm illustrating with these lines. Hold on, I might need a little bit more space than that. Okay, remember that the rows come from the first matrix. Okay, row 1 goes in row 1. So I've got negative 2, 0, 1. So here I've got negative 2, 0, 1. Row 2 goes in row 2. So 4, 2, 3. Row 3 goes in row 3. So 8, 1, 0. Now the columns come from the second matrix. There's only one column. But that's going to be x, y, 3. So I'll have x, y, 3, x, y, 3. Okay? Then you have to multiply and add. So if I multiply these together, oh, that's too big. Hold on. If I multiply these together, that's going to give me negative 2x and 0 and 3. And here I will have 4x and 2y and 9. And here I'll have 8x and y and 0. So next I'm supposed to add these together. So if I add these, look at these purple numbers. If I add these together, for the first row, I'm going to get negative 2x plus 3. All right, I'm just adding these three numbers, these three expressions. For the second row, I'm going to have 4x plus 2y plus 9. And for the third row, I'm going to have 8x plus y. And all of this then has to equal this answer matrix over here. All right, it has to equal negative 6 and 23 and 34. Okay, so take the first little equation for example. So this gives me the small equation of negative 2x plus 3 equals negative 6. Subtracting 3 from both sides, I have negative 2x is equal to negative 9. Dividing both sides by negative 2, I get x is equal to 4.5. Okay, so that's one of the variables right there. Wait, this is supposed to be an x over here. Okay, in fact, I'm going to use this, the third row right now. So looking at the third row, okay, just looking right here, this gives me the equation 8x plus y is equal to 34. But x is 4.5, so that's 8 times 4.5 plus y is equal to 34. Okay, so that's 36. So I've got 36 plus y is equal to 34. So if I subtract 36 from both sides, I get y is equal to negative 2. All right, so those are the two values I was supposed to find. And then finally for part C, we're going to do the same type of thing as we did for part B. Again, this is a 3 by 3 matrix, and then the next one is a 3 by 1 matrix. So it's good that the inner dimensions are the same, otherwise this would not be possible. But the outer dimensions tell us the dimensions of the product, the final answer. So the final answer has to be a 3 by 1 matrix. So that means I need to set up a giant 3 by 1 matrix. So that's what I'm going to do right now. So here comes my 3 by 1 matrix. Okay, so I've got 3 rows, 1 column. The rows come from the first matrix. So row 1 goes in row 1. So that's why I'm going to have 1, 2, negative 1. Row 2 belongs in row 2. So I will have 3, negative 2, 1. Row 3 belongs in row 3. So I will have 0, 2, and 4. Now the columns, or column in this case, comes from the second matrix. So I have my 1 column which will go in my 1 column. So I will have x, 2, negative 1, x, 2, negative 1, x, 2, negative 1. So finally I need to multiply and add. If I multiply here, I'm going to get x and 4 and positive 1. And this is going to give me 3x, negative 4, negative 1, 0, 4, and negative 4. Now, I need to add these together to get the answer. So, okay, this won't need to be as tall anymore. So, my first row is going to be, if I do x plus 4 plus 1, that's just going to be x plus 5. All right, that's my first row. In my second row, if I do 3x plus negative 4 plus negative 1, that's going to be 3x minus 5. And in my third row, aren't there supposed to be some, oh, the y's over, I'm like, where are the other variables? In my third row, if I add all of these up, I get 0 actually. Okay, so now this should equal the other matrix, 8y, 0. So this should equal 8y, 0. Which sets up some nice little equations for me. So that means, the first element should equal the first element. So, so that gives me x plus 5 should equal 8. Subtracting 5 from both sides, that gives me x is equal to 3. Now, looking at the second element, I see that 3x minus 5 should equal y. Well, I already know that x is 3, so really I can write 3 times 3 minus 5. All right, so instead of having 3x minus 5, that's 3 times 3 minus 5. Well, that's 9 minus 5 is equal to y, so that tells me that y is equal to 4. All right, so those are the two answers to problem number 4, part C. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.